All right, in this video, thought I'd show off some algebra. I challenged you guys about finding the formula for, if you were watching the impedance and resistance and resonant frequency. I challenged you to come up with a formula for resonant frequency, given the fact that resonance occurs when the impedance of both the inductor and the capacitor are the same. So we have 2 pi FL then is equal, when it's equal to the capacitive reactance. Capacitive reactance is 1 over 2 pi F. And of course this is times the C. And what we want to do is we want to solve this equation for F. It's really not that hard algebraically. It's really a pretty good exercise in manipulating equations, isolating an equation for a particular letter. And you're interested in doing that when you don't need a numeric value, you need another formula. And we did that some with Ohm's law equals IR, and we solved for these other two variables in turn just by doing some simple algebraic manipulation. This one's a little more of a challenge, but really not much. In solving equations of this type, solving equations of any type, it's generally good to get rid of any fractions first, if you can. And since this is a fraction, we can get rid of it by multiplying both sides by the denominator. And we'll just do it as one whole entity that way. That way this cancels this out. So we get 2 pi FC times 2 pi FL. And that multiplication is equal to 1. So, I think you can see in here, now since we want F, 2 times 2 is 2 squared, pi times pi is pi squared, F times F is F squared. So what we're going to wind up with on this side at the end of this is F squared. And then to get F, we'll have to take the square root of both sides. So rather than actually multiply out the 2's, it's 4, it's easy to do. But pi is a non-repeating decimal. Let's just leave it squared. So we get 2 squared, pi squared, our frequency squared, and then C times L. Well, we know we're going to wind up with LC. And the order does not matter when you're multiplying. So we'll just put it as L times C. So all these things multiplied together, these are equal, I don't know what happened there. These are equal to 1. All right. So the next thing in solving any equation, and particularly these little ones, remember that what we're after is this guy. Well, what's being done to it? Well, all this other stuff is being multiplied. It's multiplying this F squared. So if we divide by all this other stuff, and of course we have to do that to both sides of the equation, that will get F squared by itself. So let's divide by 2 squared, pi squared. We want to keep F squared on this side, L and C. And of course we must do it to both sides of the equation. So 2 squared, pi squared, and LC. So this cancels, and we're just left with F squared. So F squared then is our 1 over 2 squared, pi squared, L times C. Okay. So now what remains then, since this is f squared, we can get f if we take the square root of both sides. So we'll take the square root of both sides. So the square root and the square cancel each other out. We're left with f. And it's a law of radicals that we can separate factors. So let's get the square root of 1 up on top over the square root of 2 squared times the square root of pi squared times the square root of L times C. And then we'll simplify that. The square root of 1 is 1. So we get the 1. The square root of 2 squared, well, the squaring and the square root cancel each other, so we get 2. Similarly, the square root and square leaves pi, so there's our 2 pi. There's nothing we can do to reduce this, so it stays the square root of L times C. And this indeed is the formula for resonant frequency, oftentimes a subscript of R to show that that's resonant. So that goes back to show that this idea of resonancy, if we were to graph it, capacitive reactance comes down. This is frequency getting larger this way, with 0 here. And this is our reactance value. And if we plot our 2 pi FL, which is the reactance for inductor, since it's directly proportional to the reactance, it's a straight line function. So it will come out like this. And resonancy occurs where these two are equal. So all we did was make the two separate equations for reactance, inductive and capacitive reactance, equal to each other, because they're equal to each other at this point, and that will tell us what that frequency is. And that, of course, is where our formula for resonant frequency comes from. All right, thought I'd work it out for you just in case you had some trouble with the algebra, because you kind of have to be up on some of the little rules that aren't used too much, like radicals and stuff. Anyway, I hope you got a chuckle out of it anyway. All right, see you in the next video.